Okay, consider the following problem. Find all the solutions to, and I've left it as z equals 1 in this circumstance. Imagine, if you will, that the question was specifically, hold on, it says it's finishing that paint bucket. Okay, the paint bucket is finished. Imagine, if you will, that the actual values was 13 equals 1. What would you do to go about solving that? Well, you go through the following. In my opinion, you can go through the following steps. I do apologize that this is not the best on the eyes. Not quite sure why that has gone extreme in such a manner. I don't believe the rest of it is like that. Do apologize for now. But you take z13 is equal to 1. We know what z is. Cos theta plus I sine theta to the 13. De Moivre's theory brings the 13 in. It's the theta that we're interested in, though, because that's what we want to know. Find the following. Find the solutions to. The solutions are what angles of cos and sine. Of course, there's a difference in frequency because there's a 13 here. But what angles of cos and sine will allow for z to the power 13 to equal 1? Now, in these circumstances, how do I find that theta? Well, one of the things I know is that 13 theta needs to be equal to 2k pi. 2k representing the fact that you can cycle consistently. 2 pi being that, of course, because 2 times pi is 360 degrees, so that's the full cycle. The k representing that you can do that as many times as you can. But there is a boundary, as we have discussed, in that arc can only go from minus pi to pi. And so what I would do is I'd state that. I'd say I know that 13 theta can be any value, but it must satisfy, it's a phrase that I could use, we must satisfy that it has to be, or the solutions need to be in terms of 2 pi multiplied by k. Rotations around the 360, and there are infinite number that we can do. There is a minimum or a boundary. For this question, for example, if you take your time and have a go at it, you'll notice that you can go from 0 to 12. If you go further than that, you will end up with a circumstance where you are outside of the minus pi to pi arc definition, and that is, for want of a better phrase, a tradition. It's not universal, or generally it seems to be universal for most maths courses. It's just the way we define things. I do believe it has some advantages. And that is to say, therefore, because I'm aware of this, I can say, well, the theta, therefore, must be 2k pi over 13, and the k can go from 0 all the way to 12. These values of theta will allow for this equation here to equal 1. That is what we're saying. We'll allow for this, for z cubed to equal 1. And there are a lot of them, of course. There are a lot of them because k goes from 0 all the way to 12. And that's simply because in this diagram, let's say that this value here was our output value, or was the theta that we wanted. You could get 1 here, no, because it needs to be matched with sine theta. Here, the next 2k, next 2 pi, the next 2 pi, the next 2 pi, and this can go on for a value of 12 times. So I've raced through that one. We can have a further discussion about that. We're not really limited to this concept here. There's not really a reason why we can't go into a further discussion on this, but it was mainly just to give you another example of a more complicated situation, because before we started off with just z cubed equals 1. For this, I've gone all the way to 13 and just given you a way of considering the problem there. Let's also look at another problem. I haven't actually finished this off. This is probably the best way. To write it out. Once I know what theta is, I'll actually put it in there. Cos 2k pi over 13 plus I sine 2k pi over 13, where cos can come in, where k can come in these forms. Okay, so this is the next one I want to consider. This one is, I find these slightly more interesting because mainly that I've judged because omega looks quite interesting. Now consider these problems. Let omega equal cos 2 pi over 5 plus I sine 2 pi over 5. Show that omega is a root of equation z to the power 5 minus 1. Well, notice first of all that this is the equivalent of z to the 5 equals 1. So it's very synonymous to this z to the cube equals 1. In fact, some might say that it's interesting that it was put in this form there, but notice that could have been done from the beginning. I could have said z cubed minus 1 equals 0. Now, in these circumstances, we have z to the power 5 minus 1 equals 0. I'm going to deal, one way to start, though, is to deal with this straight away. If we know that this is a representation of a root, This is a representation of a root here. We've got cos 2 pi 5 plus I sine 2 pi 5. And you could sketch this. You can see what it looks like. The idea is show that omega is a root of the equation. So one trick to do is to say, well, what happens if I put omega to the power 5? What do we get? Well, we'd have this to the power 5. This we know is in complex number form, so there's no reason as to why we can't apply De Moivre's theorem. If I apply De Moivre's theorem, I'd put 5 in these circumstances. A 5 would fit in there, and in so doing, they would cancel and leave cos 2 pi, which we know that cos 2 pi would become, well, if you consider this, use this diagram so I can make it clear. If this, let's use this value here, if this is 90, 180, 270, 360, don't know why it lagged. Don't know why it lagged there. That wasn't the most intense thing for my laptop to do. 90, 180, 270, 360. At 360 we have 1. So if it was 2 pi, we'd also have 1. And in these circumstances, therefore, that is 1. I sine 2 pi, this will produce a value of 0. Again, I can do that very quickly. Do apologize if you're very comfortable with it. But again, pi over 2, pi, 3 pi over 2, 2 pi, there is our bad boy there, it is 0. So this is exactly the same as this cos 0 plus I sine 0, just in a more stylish manner, and so therefore it's equal to 1. We know that for the z cubed equals 1, the original 1 is a value of 1. There will be no difference for z to the 5, because it would go through the same process. Z to the 5 equals 1, you'd have Z equals 1 1/5. So Z is equal to 1. So the first value that solves this is just 1. It's the same for Z to the power 5. So by definition, it must be a root because it's 1, and 1 is always a root of Z to the power something equaling 1.